Hello everyone, welcome back to our channel Quantum Explorer. In this video, we will talk about multiple recursion call, which is the third part of our recursion series. In this video, we particularly solve this question and understand what is multiple recursion, how to deal with it, how to find base case without any mug-up. Let's begin. Let's see what is the Fibonacci series. Fibonacci series means in Fibonacci series, first two terms are 0 and 1, and next terms are the sum of previous last two terms. Means third term is 1 plus 0, 1. Fourth term is 1 plus 1, 2. Then 2 plus 1, 3. Then 3 plus 2, 5. 5 plus 3, 8. 13, 21, 34, and so on. So this is Fibonacci number. It means that if you want to find nth term is nothing but n minus 1th term plus n minus 2th term. And if I want to find f of 5, it means that it is f of 4 plus f of 3. So this is what about Fibonacci series. Let's solve this question. Here we have two approaches. First approach is for, and it is quite easy that first of all we'll declare f of 0 is equals to 0, f of 1 is equals to 1, and 4 in I is equals to 2, I less than or equal to n, I plus plus, and it will return, and it will work like f of I is equals to f of I minus 1 plus f of I minus 2, and ultimately we can get f of n. But of course we are here to learn about recursion, so we can't follow this approach. We follow recursion approach. In recursion approach, first of all we have main function. Outside the main function, let's say I make a function named Fibo, which take only one parameter n as integer type. In Fibonacci series, what it should do, it should only returns f of n minus 1 plus f of n minus 2. Let's first of all understand what is the mean of this line, and after that we add the base case. Let's say in n is equals to 5, and we want to find f of 5. Okay, so what this function will do, this function will return f of 5 is equals to f of 4 plus f of 3. Again, this function is called for f of 4, so f of 4 will return f of 3 plus f of 2, and f of 3 will work for f of 2 plus f of 1. F of 3 again called for f of 2 plus f of 1. F of 2 is called for f of 1 plus f of 0. F of 2 is called for f of 1 plus f of 0. F of 1 is called for f of 0 plus f of minus 1. But wait, it can't have a value of minus 1. Fibonacci number is only for positive number. So that's here we find the base case. See, base case is not the mug up thing. It is think about find the logic behind the series. In series you can see Fibonacci number is for only positive number. So we have problem in f of 1 and f of 0. So initially we have value of f of 0 and f of 1 as 0 and 1. So what is our base case? Our base case is that if n is equals to 0, return 0, and Second condition is if n is equals to 1, return 1. So this is simple code of recursion, and here we see the function is called twice time for recursion. Why this is important? Because in next to DSA concept like trees, graphs, and DP-like concept, multiple time recursion is very common. So this is the base question to understand about multiple recursion. In main function, after few lines of code, we call this f function for our integer variable n, which we take from user. Let's understand by example of 6. N is equals to 6 in recursion tree. Let's say first time function is called for f of 6 as n is equals to 6. So in function, what will be written? F of 6 is called for f of 5 and f of 4. This is n minus 1, this is n minus 2. F of 5 is called for f of 4. F of 5 is called for f of 4 and f of 3. And f of 4 is called for f of 3 and f of 2. F of 4 is called for f of 3 and f of 2. F of 3 is called for f of 2 and f of 1. F of 3 is called for again f of 2 and f of 1. And f of 2 is called for f of 1 and f of 0. F of 3 again called for f of 2 and f of 1. F of 2 is called for f of 1 and f of 0. Here also f of 1, f of 0. F of 1 has its own value. F of 2 is called for f of 1 and f of 0. Here again f of 2 is called for f of 1 and f of 0. Value of f of 1 is 1 and 0. F of 0 is 0. So value of f of 2 is 1. Value of f of 1 is 1. So value of f of 3 is 2. We know value of f of 1 is 1. Value of f of 0 is 0. 1, 0, 1, 0, 1, 0. Value of f of 2 become 1, 1, 1. And value of f of 1 is 1, 1. This branch is completed. Let's now move towards this branch. Here value of f of 4 is f of 3 plus f of 2 means 2 plus 1, 3. Value of f of 3 is 1 plus 1, 2. Value of f of 3, 2. Value of f of 2, 1 plus 0, 1. Now move towards this branch. Value of f of 5 is f of 4 plus f of 3 means 5. Value of f of 4 is f of 2 plus f of 1, 3. And our answer is f of 6, which is f of 5 plus f of 4 means 8. And initially in series, as I say, is 0. Series is like that: 0, 1, 1, 2, 3, 5, 8, 13. And you can see this is f of 0. This is f of 1, f of 2, f of 3, f of 4, f of 5, and f of 6, which is 8. And we get it by our recursion tree also. So this is all about multiple recursion. This is the base question. In further videos, our team member will solve more question on multiple recursion. So keep watching our videos.